My name is Kennedy Kibetu. I am a technical engineer here at Jubilee Bros Solar East Africa, and I'm based in Nairobi, Kenya. Welcome to today's topic on PV diesel hybrid solutions. We'll start on with an introduction as to who Jubilee Bros Solar is, and then we'll go into the PV diesel hybrid solutions. So welcome, and if you have any questions, any comments, feel free to leave that at the comment section, and let's continue this webinar. So an introduction as to who Jubilee Bros Solar is. Jubilee Bros Solar is a division of Jubilee Bros, and Jubilee Bros has been a leading provider of power solutions in Middle East and Africa. Jubilee Bros has been doing diesel generators for the past 45 years and recently branched into a solar division. And so you're confident in knowing that you have a full scale of power solutions for your needs. Below, you can see the chronological order as to how Jubilee Bros has evolved and expanded into different regions and different areas of this world. It started in Lebanon in 1977, moved to the UAE in 1992, proceeded to Nigeria in 1996. And it's of importance that I mention that in Nigeria, we have one of the biggest staff numbers, over 1,000 employees in Nigeria, as well as over the last 3 to 4 years, we've done 3 gigawatts of diesel generators in Nigeria. So we have been in the generator market and now moving into solar. In 2002, went to Afghanistan, then Kuwait in 2004, went to Ghana in 2010, Qatar in 2011, moved to Uganda in 2013, and South Africa in 2016. Then in 2017, that is when the solar division was established. And from there, we've continued to grow into Pakistan in 2020, Kenya in 2020 as well, and we are proceeding into more and more regions in 2022 and beyond. I can see someone here saying that they can't hear me. Please let me know if you can hear me through the comments. Kindly let me know if you can hear me before I proceed on to the next slide. All right, someone says they can hear me. So for the people who can't, kindly check on your sound settings. All right, you can see there a map of Africa, Middle East, and Europe, and every place where there's a flag, we have a sister company, we have representatives, we have offices or distributors in those regions. And it's important to note that these are very hard logistical areas to reach. So you're guaranteed that through Jubilee Bros Solar, you can get your equipment in those hard to reach areas. These are our 6 pillars of supporting our EPC customers. We start with product supply, where we provide products and solutions through distributors in Middle East and Africa, and we are able to provide quick delivery. We also do trainings as one of our key initiatives. We do provide custom trainings to our clients, as well as weekly webinars like these ones. Another pillar of support is on engineering support, where we have engineers who are specialized in design, in installation, and commissioning of solar systems. And they can go through your designs and validate them and make sure that your designs are up to standard and you have the optimal solution available. We do offer leads to our EPC customers through our vast connections in the market, and we can identify opportunities and pass them along to our EPC customers. We also do provide referral to finance. We have connections and relationships with financial institutions, and we are able to help our EPC customers to find financing for their customers for their solar systems. And then finally, one of our biggest support areas, we do offer after sales support. Our engineers can assist in site support, be it physically or remotely. We can do commissioning of solar systems, and we do offer after sales maintenance and support, be it through timely warranty support, commissioning support, and maintenance support. Bailey Bros has a partnership with Huawei. We are the value-added partner as well as certified solutions provider for Huawei. And with Huawei products, you're guaranteed to have more and higher yields. You have smart operation and maintenance procedures, and you're assured of safe and reliable products. All right, now we move into the meat of the matter, the PV diesel hybrid solutions. Why are we looking at a PV diesel hybrid solution? Here we have two separate solutions that have been combined to offer one single solution. You have the diesel generators that operate as either a backup or as a main supply, and then we have the PV solution that can also be used as a backup or as a main supply. So why do we consider having a PV hybrid solution? One thing is to look at the LCOE. This is the levelized cost of electricity. And what LCOE is, it is a measure of the operating and capital expenditure over time of the plant against the total electricity generated of that plant over time. And as you can see, we have the capital expenditure plus the operating expenditure over the lifetime of the plant against the total electricity generated. And this LCOE number is what financial institutions will look at, is what customers will want to have as low as possible LCOE to have the maximum gains and maximum return of investment. So in the PV diesel hybrid solutions, we have two components. We have the diesel generator side and we have the PV solar side. So we look at the diesel generator side. What are the benefits of diesel generators? We have their reliability and their relatively low upfront costs. And generators have been used over time as backup solutions or as main power solutions in areas where there are no grids or the grid is very, you have fluctuations in the grid. However, we have challenges when it comes to diesel generators. They do give pollution because of the exhaust gases. They have a high operating cost, and this is due to the cost of diesel fuel, as well as logistical costs still coming from the diesel fuel. You need to look at the transport of the diesel fuel. You need to look at the storage of diesel, as well as the security, because you can have areas where the diesel can be stolen while still in transit or stolen while in storage. And this is how the diesel prices have been in East Africa. You can see from 1992 to presently, we have had a continuous increase of diesel prices in East Africa. And this is also a global trend that we're seeing. And especially this year, we have seen a sharp increase in global fuel prices, meaning the price of diesel has continued to rise and to rise. There was a dip around 2016, but this was a glitch in the system. However, this price has continued to go up and it will continue to rise, meaning that the cost of operating and running diesel generators will continue to increase and go high. So where and why does a PV diesel hybrid make sense? So a PV diesel hybrid will be considered in remote areas that have been unserved or are underserved by the grid. These are areas where the grid has not reached or there's very intermittent power from the grid. We also want to consider a PV hybrid solution when the cost of diesel exceeds $80 per liter. And this is the case that we are seeing today. Due to the increase in global petroleum prices, we have seen a sharp increase in diesel fuel. We also consider areas or places where sunlight is abundant and you can take full advantage of solar in these areas. We also consider places where generators run in the daytime hours. You want to reduce the amount of diesel that you're using or the amount of time that you're running the diesel and increase the amount of solar to compensate for that window. We also look at areas where logistics costs associated with the diesel are high. And we saw this when transporting and storing and also safeguarding the diesel. These costs continue to rise and rise. So a PV diesel hybrid solution would make sense in areas like this. And we also consider areas where storage and security of diesel is a concern. With the high increase in diesel prices, it has become first a scarce commodity as well as a very expensive commodity, meaning people will want to steal that diesel and sell it. And also in areas where generators are being used as a main source of energy, there's that daily cost of diesel that needs to be put when budgeting. So you need to look at how do I reduce the cost of running and operating a generator. This is where a PV diesel hybrid solution can come in. So we talked about the levelized cost of electricity, and now here we see a comparison between the LCOE of solar and the LCOE of diesel. From yesterday, today, and tomorrow, we see the cost of diesel has been on a continuous rise, and it continues to rise and will continue to rise in the future. However, the cost of solar continues to come down, and there is also a sharp decline in the cost of solar components, from the modules to the inverters to the cabling. So the overall cost of solar installation and operation continues to come down. So this gap, the gap between the cost of solar and the cost of diesel, continues to grow bigger and will be bigger and bigger into the future. So when considering the LCOE and why the PV diesel hybrid solution makes sense, is because the cost of solar, the levelized cost of energy of solar is very low, and the levelized cost of diesel is high. So incorporating the PV diesel hybrid solution, you're trying to get your overall levelized cost of electricity low. Since you'll be integrating solar into your diesel solution, you're slowly lowering the overall levelized cost of electricity. Next, we look at how the PV diesel solution works. Here we have three major components that make up the PV diesel hybrid solution. We have the PV array system, which consists of the solar panels, the mounting structure, the DC and AC cabling, as well as the PV grid inverter. Then we have the diesel generator, and these two make up the PV diesel solution. And then we have the load. And what makes this whole solution come into play is the fuel safe controller, or the control system that incorporates the PV and the diesel. and helps them work hand in hand. So the fuel safe controller is what is an intelligent management controller that controls the mix of solar and diesel and makes it a viable solution for the load. So why does a PV plant need the PV diesel controller? We need to make sure that the overall system works in a smooth and efficient way. So this is achieved by controlling the PV plant, making sure that you're generating and maintaining the maximum PV output. You want to achieve a high proportion of PV without impairing the stability of other power sources. And other power sources in this case could be the diesel generator, battery storage systems, or the grid. And then you want to monitor the flow of energy from, is it coming from the PV side? Is it coming from the grid? Is it coming from the generator or the battery storage system? So you want to monitor the flow of energy throughout the entire system and to make sure that when switching on between the systems, this does not affect the stability of the system. So ideally, we have two functions. We have the protection function where you want to protect the generator, you want to protect the load, and also protection from the grid, as well as performance. You want to make sure that your PV plant is operating at an optimal level and that you're maintaining a maximum PV output and ensuring that you have a constant supply to the load. And we look at how each of these plays in the system. When you come to the protection side, we have generator protection. You want protection when it comes to minimum loading. You need protection when it comes to reverse power. Power management, you need to have good power quality. You also looking at spinning reserve. You don't want your generator to constantly switch on and off, on and off. As well as from the grid, you want to also make sure that you have good power quality from the grid, as well as control feed-in, because you have areas where you are not allowed to send power back to the grid. So you need to set feed-in or limitation control. As well as performance, you want to make sure that the output from the PV side is at an optimal level and you're maximizing the PV output, as well as making sure that you have a constant supply of power to the load. And we look at each of these individually next. So protection, generator protection when it comes to minimum loading. Minimum loading in generators, and this is where you cannot go beyond a certain limit in relation to the power rating of the generator, and this is usually between 30 and 40%. And when you go below that minimum load limit, you can affect your generator negatively. And this is usually seen in the form of soot deposits in the cylinder. You have wet stacking of soot deposits in the turbo, as well as carbon deposits in the linear, piston, and injector nozzles, as well as a high crankcase pressure, both front, rear oils, seal leaks, as well as oil leakage from the manifold and exhaust. So operating your generator below the minimum loading rate will reduce the lifetime of your generator. So how do we protect the generator from minimum loading? Since you have high PV, and you want to make sure that your generator is performing optimally, the controller will reduce the output of the PV system or also switch it off entirely to make sure that your generator is operating above the minimum load rating. So the controller can switch off or reduce can switch off or reduce the output of the PV system so that you can maximize the output of the generator and protect it, um, so that you're not operating at the below the minimum rated load. Next is reverse power protection. So reverse power protection is when, or rather reverse power is when power goes back to the source. In this case, when power goes back to the generator. Most generators have a limited reserve power window, and others will have their own protection on reverse power. So to prevent reverse power, the controller will cut off feedback from either the grid or the solar or from the battery, and reduce the power that is coming from those other sources so that they are not fed back into the generator. This can be through curtailing of the PV system or reducing the power from those other sources. As you can see from the images below, we have a load that is 100 kilowatts, and we're getting 70 kilowatts from the PV array and 30 kilowatts from the diesel generator. When the load drops to 40 kilowatts, we'll see we'll have the excess power from the PV array that can be sent back to the diesel generator. However, with the hybrid controller, it can reduce or completely cut off the power coming from the PV side so that it does not flow back into the diesel generator. And so that is how the controller helps in reverse power protection. Next is power quality management. This is to ensure that, or to adjust the reactive power during operations and make sure that your DG is maintaining stable, is operating in the stable window. Here in Kenya, we have power quality of between 0.8 and 1. And if you go below that power factor, you get penalties from the utility company. So to make sure that you're operating within the set limits, the hybrid controller will be able to adjust the power quality so that you're operating within the optimal level. Next is still on the generator protection when it comes to spinning reserve. And this is to maintain the spinning reserve so that you do not have that on-off, constant on-off switching of the generator. When when you have cloud cover, you can have your PV generation drop to almost 80% of the installed capacity. So this will mean that due to the fall of the PV generation, your generator kicks in. And then when the cloud cover goes, the PV capacity increases and then your generator shuts off. So this continuous on off can be detrimental to your diesel generator. So in an event of major load changes or a sudden drop in PV generation, there's always sufficient spinning reserve that will be available, and this will be controlled by the hybrid fuel save controller. So you are sure that first, you're not constantly switching on and off the generator, and you have enough spinning reserve such that when generation from the PV goes down, your generator kicks in and works hand in hand with your PV. Then another feature when it still comes to, now this is in grid protection. where we have export limitation. In several countries, we are not allowed to export power from, let's say, the diesel generator or from the PV back into the grid. And in this case, if PV power is not allowed, or they are set limits as to how much power can be sent back to the grid, the hybrid controller can be able to set these limits, or even cut off feeding into the grid. And you can see here we have, again, a load of 100 kilowatts. We have the PV array of 90 kilowatts, 10 kilowatt coming from the grid. So when you have more generation coming from the PV, more than what is required by the load, the excess won't be fed into the grid. And this is where the hybrid controller sets this limit or acts as zero feeding into the grid. So you have, again, grid protection. So in summary, we have generator and grid protection, where you want to make sure that you're not causing damage to your generator, as well as not feeding back into the grid. And you're integrating the PV solar system into your existing DG to reduce fuel costs and also guarantee constant and efficient electricity supply. So what is this fuel save controller or hybrid controller that enables these two systems to work hand in hand? We have what we call the Encombi ECPVX. And the ECPVX is a small component that comes in this EC cube. And the EC cube has 5 Ethernet switches. It has the ECPVX. This ECPVX is the specific controller. And then you have the power supply, the circuit breaker, the terminals for mounting communication cables, as well as power cables. And it has the HMI, the human machine interface. In this case, it's the EC panel 7. So what is the ECPVX? This is the controller that controls the PV, battery, diesel, and the grid. So it integrates all these different sources of energy and makes them work hand in hand. It has been designed to work with both AC and DC coupled systems, and it integrates with different power components regardless of vendors, be it the diesel generator, the PV array system, the battery energy system, as well as the grid. So the ECPVX will work with whatever brand of diesel generator or PV system that you're working with. So the ECPVX, the specific fuel save controller, has a software that runs on an industrial PLC. PLC is a programmable logic controller. And in this ECPVX, you have the software and license that is built in, and you have the hardware component. And the hardware components, you have the Ethernet port, 1 or 2 RS-485 serial ports. You have an SD card where you can save your data, and a USB port. The power supply is 24 volts DC, plus or minus 15%. It has an operating temperature range of negative 20 degrees Celsius to 70 degrees Celsius. And these are the rail mounts requirements, as well as the dimensions of the ECPVX. So what does the ECPVX do? What does it do? It maintains proper and a fixed power quality, be it active or reactive power, from the grid or from the diesel generator, as well as maintains the import-export from the grid. So you have proper power quality management, as well as export limitation from the grid. And it also charges the grid at set rate if allowed. So if you have a situation where you need batteries to be charged from the grid, the fuel safe controller is able to uh, make that happen, and you can set the parameters unto which the battery system will be charged from the grid. When working with the generator, what does the fuel safe controller do? So it maintains a fixed minimum operating load on the generator. We had seen earlier that operating below the minimum rated load is going to be detrimental to your diesel generator, and you want to extend the lifetime of your diesel generator. So with the integration of the fuel safe controller, you're making sure that your generator is operating above the minimum rated load, and it shares the reactive load with the genset, again making sure that you have good power quality. And it also allows charging the battery from the generator if that setting has been put in. So in this case, with the fuel safe controller, you can charge your battery system from the grid, as we had seen earlier, or from the diesel generator. Then, when working with the PV system, what does the fuel safe controller do? It acts as a voltage reference for the PV. Here, since it's communicating with the grid and with the diesel generator, it gives the PV system a voltage reference for each to operate optimally. And then it will control how much power is coming from the PV to the load. In this case, you want to make sure that you have all the available PV being taken to the load. So the fuel safe controller will make sure that as much PV as possible is being fed to your load. And it also shares the reactive load with the PV plant, and it allows charging of the battery system from the PV. So again, when it comes to the battery storage system, you have the option of charging from the grid, from the generator, or from the PV array. And this you can set on the fuel safe controller. So this is how the PV or the ECPVX interface looks like. It works purely on communication. This can be on the Modbus protocols, either TCP or RTU, and it supports interfaces listed below. This you'll be able to get once the webinar is over, and you can see it. You have different interfaces for the generator, for the solar inverters, for the battery inverters, as well as for the power meters, and more can be added on customer requests. And this is a line diagram of how the fuel safe controller can work with the PV and generator on off-grid settings. One thing to note is one hybrid or one fuel safe controller can work with up to 16 pieces of generators and up to 32 inverters. So it is not dependent on capacity, but on the number of generators and inverters you have. So regardless of your installed capacity, it will work with 16, up to 16 generators and up to 32 inverters. And this is how it works with the PV genset when it's on grid. And previously, we do not have the grid integrated into the system. And now we have the grid integrated. Then this is the line diagram when you integrate the grid, the diesel generator, as well as the PV array. One thing I'd forgotten to mention is other than the fuel safe controller, we do have controllers for the generator and the power meters for on the PV side. And on the fuel safe controller side, other than the PV ECPVX, we do have the monitoring platform as well as the cloud solution. So EC Cloud is Ncombi's web app where you can get live and historical data. So this is the monitoring platform for your fuel safe controller, and the features are it is easy and straightforward with the user interface and the menu system. So it is easy to work with, and it has a small learning curve. You can use it with any brand of PV inverter, power meter, and generator controller. It uses, you can get, in terms of monitoring, you can get graphs of production references and measures from inverters, power meters, generators, and sensors. And that is on a 24-hour period, as well as 30-day analysis of energy generation, and curtailed whether the energy was, how much energy was generated, how much energy was curtailed, as well as the revenues and savings. You can have 12-month analyses, again, of energy generated or curtailed, as well as revenues and savings, and the same for 10 years. And so in terms of monitoring, you can get a ton of information on how your PV diesel hybrid is working. And this is how the setup looks like. The ECPVX has an inbuilt web server that is referred to as the EC Web. And the EC Web again helps you monitor and see, or is the interface between your system and your HMI. You can run it on your PC, on your mobile device, and you're able to see the parameters of your PV hybrid solution. One of the other components that was in the EC Cube is the EC panel, and it's a plug and play touch 7-inch touch screen where you can monitor the daily operations of your plant. So this information is available on the screen on the EC Cube, and this is for local monitoring. And if you want remote monitoring, you have the EC Web, which will give you the same information as what is on the EC panel. And then we have the EC Cloud for data logging. So it's a portal that holds historical site data, and you can have visual analysis of and historical analysis of your data. So then again, this is included in the ECPVX solution. And this is how the ECPVX is designed into projects. Here we have three different energy sources. We have the grid with its meter, we have the PV array with its meter, as well as the genset with its meter or controller. All these are connected to the ECPVX. And from here, you are able to monitor on the EC panel or on remotely on your computer or on your phone. Or another source I'd forgotten to mention is the battery solution. So with these four sources, they can all be controlled by the ECPVX, and all this information is relayed through the EC Cloud to your monitoring platform. So this could be through remotely or on the EC panel that is on the N-Cube. So this is integration only when you have the diesel generator and the battery solution. So both integrated into the ECPVX, and you have local monitoring as well as remote monitoring. And the typical sequence of operation is generator will start and synchronized, then the battery is charged when the generator is operating at the optimal. And then when the state of charge of the battery is high, the genset will be unloaded, and then energy will flow from the battery. And thank you. Please feel free to ask your questions on the comment section. So we have a question from Ganga from Nigeria. What will be the effect of sunlight fluctuation on the control of the power management? So as we had seen earlier, due to the fluctuation of sunlight on the PV side, the fuel cell controller will be able to switch from the PV to the diesel generator, or in this case, could also be from the grid or from the battery solution. So the fuel cell controller is able to detect what the load needs, where the best energy is supposed to come from, while still protecting the diesel generator from the minimum load. So in this case, if let's say you don't have any other solution integrated, you only have the PV and the diesel generator. When you have a sudden drop or a fluctuation in sunlight, then the diesel generator will kick in. And we'd seen earlier on the spinning reserve, the fuel cell controller will make sure that there is enough spinning reserve to prevent the constant switching on and off of the generator when the sun fluctuates. So that is how the fuel cell controller is able to regulate power generation from the PV and from the diesel generator. Andrew asks, please, can we get the slides? Yes, the slides, you'll get this presentation automatically in your emails after this webinar ends. So Elaine asks again, what about reliability due to clouds? What is the average time before taking the load from the generator? Is the generator every time stopped when solar meets the entire load, since it's an on-grid inverter? Is a generator that gives the reference, that is voltage and frequency. So when operating on-grid mode, you can have the generator come in as backup, meaning your references will be on the PV and the grid side. So when clouds come in, or rather when you have a fluctuation due to cloud cover, then we'll have um, you'll have energy coming from the grid. And in this case, your generator will be acting, since you have an on-grid solution, your generator will be acting as a backup. When again the grid fails, this is when the generator kicks in. So I hope I have answered your question. Again, what is the impact on LCOE when adding storage for peak shaving? So when it comes to renewable energy, especially on the PV, one of the most expensive components of a PV solution or a hybrid PV solution is on storage and batteries. So with adding of storage for peak shaving, your LCOE will significantly increase um, due to the addition of storage. However, given that you have these batteries, if you're using lithium-ion batteries, you have them lasting for around 10 years, it still will be better than what you have with diesel generators due to the constant buying of diesel or from the grid. So the LCOE will be impacted, but it also won't be as bad as when you're only relying on diesel generators. So will the power control work with older generators and mechanical generators? And is there a recommended generator specification? So as we've seen earlier, the fuel save controller will work with any generator regardless of vendor. So it should be able to work. However, you can look at the specifications on what a combi has, and you can be guided from that. Does the E-Cube require an auxiliary or secured UPS? No, it does not. What are the warranty terms for the ECCube system? You can email us after this webinar, and then we can give you more information on the ECCube. Then Idris asks, from what capacity of your genset is compatible with the hybrid controller or a hybrid connection? As we'd seen previously, you do not, the limit is not on the capacity, but on the number of gensets that will be connected. So in this case, we've seen that you can connect up to 16 generators and up to 32 inverters. So your limit is not on capacity, but on the number of connected devices. Is the hybrid controller different from the PV diesel controller? You use the terms interchangeably. No, it's not different. It's fuel cell controller or a PV diesel controller. In this case, a PV diesel hybrid controller. Are there possibly software upgrade challenges? None that have been spoken about so far. Is this presentation recorded? Yes, it is, and you can you can view these webinars on our YouTube page, Jubaili Brew Solar, and you can get also a ton of information from other webinars. Thank you very much to everyone who's tuned in, to everyone who's commented and asked questions. Hope to see you on the next webinar. Thank you.